In Python, these categories are called data types, which include strings, integers, floating point numbers, booleans, the null type, and later on, lists, dictionaries, and more. The string type str is a sequence of characters that represents text. It's typically wrapped in either double quotes or single quotes. You can use the len function on a string to get its length. When calculating the length, spaces, numbers, and symbols each count as one character. But note, if there's an escape sequence, like a backslash followed by n for a new line, the entire escape sequence counts as just one character. You can also extract a single character from a specific position in a string. By placing square brackets after the string and putting an index inside, you can pull out the character at that position. Think of the index as a position number, but unlike in daily life, in programming we start counting from 0. The first index is 0, the second is 1, and so on. So if I want the fourth character, I'd use index 3, which would give me the character L. The integer type in Python is int, and floating point numbers are called float. Operations with these were already covered in the earlier video on math in Python. Since number notation and arithmetic are fairly intuitive, I won't go into detail again here. The Boolean type, bool, only has two possible values, true and false. True is written as true, with a capital T, and false as false capital. Even though booleans only have these two values, you'll soon see how essential they are when we get to logical conditions. For now, just remember they exist. There's also a special type called the null type, none type. It has only one possible value, none. None is not 0, not an empty string, and not false. It means no value at all. If you know you'll need a variable but don't yet know what value to assign, you can start by setting it to none. Now it is practice time. First, let's try finding the length of a string, define a variable a, and assign it the value hello world. Then we can use the while function to get its length. If you run the code now, you'll still see nothing because we need to use a frame print title to see the returned value. Run it again now, and you'll see the result is 12. This is because spaces and punctuation marks also count as one character each. Next, let's try accessing individual characters from the previous string using indexing. Always remember that indexing starts from 0. So if we want to get the letter H, we should use index 0, not 1. Print it, run the code, and you'll successfully retrieve the first character. What's the index of the last character? Since the total length of the string is 12 and indexing starts from 0, 0, 1, 2, 3, and so on, the index of the last character should be 11. Print it to see. Yep, you successfully get the exclamation mark. Alternatively, you can combine it with the silent function, where the index is the string length minus 1, and you'll get the same result. Now let's define some Boolean type data. Assign the variable fun_db1, the value I'm true, and the foo2, the value I'm false. Their first letters must be capitalized. If you use lowercase, Python won't recognize them as Boolean values. Look, an error has already appeared. Also, don't wrap them in quotes, or they'll become strings. Let's revert them back to Boolean types. Next, define a variable of the null type. Set tween to tween none. The first letter n must also be capitalized, otherwise Python won't recognize it. Now, to verify the types of the variables we defined earlier, we can use the SwiTypePy function, one by one. For example, typepy r, where ia is the first string we defined. Let's print it and see. It shows the string type. Then try type b1. Printing it should show the Boolean type. For typetypen, since dobing n.value type, it should print diving none type. You can also use typeby on the floating point numbers and integers we learned earlier. For example, type 1.5 since there's a decimal point, it should be the floating point type, float_, not the integer type, int. Finally, let's see what happens if we use a function on the wrong type. For example, if we try to use the filen function on the Boolean value ibb1, running the code will show that Python directly reports an error. Therefore, understanding the type of the object you're working with is crucial.